Okay, so good day to our Makati Science High School students. For this video lesson, we'll try to discuss a special problem on area. So we have here a cyclic quadrilateral or a kite inscribed inside of a circle. We call it a cyclic kite. Okay, so for here we have Daniel, Nicholas, and Martiza need to create the perfect kite for their arts and technology integrative performance task. To do this, they drafted and inscribed in a perfect circle, a kite. They only know the side measurements of the kite as shown on the figure on the left. So what is the area of the said kite? Okay, to solve this problem, first you're going to need the area of the kite, which is given by the formula d sub 1 times d sub 2. Or we need to first find the measurement of the first diagonal, the shorter diagonal, and d sub 2, the longer diagonal. But for this problem, it would take us quite some time to find the diagonals. So therefore, we're going to use an alternative formula or another formula that we call the Brahma-Gupta's formula for cyclic quadrilaterals. Okay, and the figure that we have here is indeed a cyclic quadrilateral, which has 4 sides and all of its vertices, so they're inscribed in the circle. So what does the Brahma-Gupta's formula state? So the area of any cyclic quadrilateral, it's equal to the square root of the first side, the semi-perimeter minus the first side, multiplied by the semi-perimeter again, minus the second side, multiplied by the semi-perimeter once more, minus the third side, and the semi-perimeter minus the fourth side. So what is the value of the semi-perimeter? From the word semi, so that means it has to be a part of the perimeter or something that's divided by 2. So therefore, we just have to add all of its sides, hence the name's perimeter, since it's a semi-perimeter, you divide it by 2. Okay, so for this problem, we have 4 sides, so we're given 5 inches. Okay, 5 inches. We're also given 1 foot and then 1 foot. Okay, notice that the units are not the same. So since the highest unit here is in inches, so let's try to find the area of the kite in squared inches. We're going to try to convert the unit measurement for feet or for foot to inches, and that would give us 12 inches. Because 1 foot is equal to 12 inches, and the fourth side would also be 12 inches. Now that our given is standardized, or all of the side measurements are in inches, we can now solve for the semi-perimeter of this given quadrilateral, and that's just gonna be A plus B plus C plus D divided by 2. And since we already know the side measurements, we just simply have to substitute these values in this formula. So that's 5 plus 5 plus 12 plus 12 divided by 2. And what's 5 plus 5? So that's 10. 10 plus 24, so that should give us 34. So this should be 34 divided by 2. Okay, and what's 34 divided by 2? Most likely that will give us 17. Okay, so for this problem, our semi-perimeter, the value of S is just equal to 17. Yeah, so again, that's 10 plus 24 divided by 2, which is 17. Okay, so therefore, now we can substitute all of our values neatly here on Brahma-Gupta's formula for cyclic quadrilaterals. So we have here the area of the kite is equal to the square root of 17 minus 5 times 17 minus 5 times 17 minus 12 times 17 minus 12. The 4 sides that we have for our cyclic kite. And what's 17 minus 5? So that's 12. Okay, let's repeat that. That's again 12. 17 minus 12 is just 5. So you have 5 here and then we have 5 here. So what's 12 times 12? So that should give us 144. And 5 times 5 is just 25. And what's 144 times 25? You can use your calculator. 144 times 25. So that should give you 3,600. Okay, the square root of 3,600. So therefore, solving for the area of our cyclic kite, what would be its area in squared inches? That would just be the square root of 3,600, or most likely that's just 60. There you go. So therefore the area, okay, I'm sorry. So therefore the area of the cyclic kite is just equal to 60 squared inches. And we didn't have to find the area by finding the diagonals. Okay, so we can do that, but it would take us some time to find the first diagonal and the second diagonal. So we use the shortcut by using Brahmagupta's formula for cyclic quadrilaterals. And that's how we solve this problem.